Guys, I think every website on the internet might have this problem. Can you see it right there or on Discord right there? And you could get around it by having this like huge blocking loading page like Twitter or Instagram does, but obviously that's not great. And I was able to discover a solution. So let's talk about why this happens in the first place, and then we'll go over how to fix it. Really, the key to understanding why this happens is understanding the different phases that kind of your code and a request goes through, from the build time to the server all the way to the client. And what's important to know is that certain information is only available during certain phases, and that's what can kind of cause these flashes where we have to go from a state where information wasn't available to a state where an information is available. So I prepared this diagram, and let's break it down. So the first phase is build time. And at build time, we have access to certain information. So we have access to environment variables, and we have access to APIs, which we kind of fetch once at the very start, and then they're kind of like locked into our build outputs. Now, build time stuff, this is also called like static stuff, or like static site generation is kind of, that's all under this umbrella. It has some really big benefits. So because we're doing this all the way up front, we can cache the outputs extremely heavily. We can put them on a CDN and serve them really close to our user and tell the browser to cache those assets. But we also have a lot of constraints, right? So we don't know anything about the individual request, right? We don't know where it's coming from. We don't know the query parameters. We don't know the headers. We don't know the cookies. We don't know if the user's authenticated. We don't know all this stuff, and we have to pre-render the page anyway. So there's only so much information we have, but we get the benefits of it being really, really fast. So now, if we cross this kind of static dynamic boundary, we move into request time mode, but still on the server. And so in this mode, we have access to all the previous server data. So we still have access to environment variables. We still have access to data that was fetched at build time. But we now have access to APIs, so we can fetch on demand, and we can fetch those on demand based on user data, right? So we can look at the URL, we can look at the headers, we can look at the cookies, we can derive a lot of like information about the state of the world and the state of the request. And the benefits for this one are also authentication is really easy, right? Like if you're calling an API, you can just use the environment variables. You don't have to think about doing authentication. And this is not like user authentication. This is like third-party API authentication. And then also like bundle size doesn't matter, right? Because you're still on the server. So just like importing lots of libraries doesn't really matter. But this mode still has a couple constraints, which is that here, if you spend a lot of time in this phase, you kind of block the rest of the phases, which is particularly painful. And that's because the next phase is paint, right? And so paint is when like the user first sees something on their screen. So if you spend lots of time in request mode, then when the user like enters your URL, they're literally staring at nothing for like, up to like as long as this request phase takes. And so often we want to kind of reduce everything we can to get to a like first paint as fast as possible. And so different frameworks have different tools for how can we like combine static and dynamic to like get the benefits of like a static super fast first paint while still having like dynamic request time data. But it doesn't kind of change the fact that both of those like phases have access to different data. So now when we move into paint, this is like your document sends, your server sends down an HTML document, and the browser kind of displays that to the screen. And so here we have access to the DOM, because the DOM is kind of been, that HTML document's been generated. And we also have access to like browser globals. Like if you could imagine you're like in an inline script tag, you can read from the window object, you can read from the document object, you can make fetch requests in theory, but like you probably don't want to. You can read information about the user, like if they have a GPU or if they have access to certain permissions. Now, the benefits of this stage are you can control what the user first sees, right? Because whatever is like in that HTML document or like happens very, very quickly after the browser receives it is what the user is first going to see. So if we want to eliminate flickers, which is what we saw in the examples at the start, then we're going to have to pay a lot of attention to this phase to make sure that we get a perfect first paint and we don't have any changes before the next step, which is hydration, which we'll talk about in a second. And kind of lastly, the constraints about the paint phase are you're literally writing inline script tags because the alternative is like you want to be writing your code in like a framework, and we're going to be mainly talking about React here. And so if you're doing something at paint mode, that's happening strictly before React. And so you're basically writing inline script tags. So once that first HTML document is loaded, then React starts up, and this is where hydration happens. And so hydration is when React is kind of initializing itself on the kind of already built HTML document. Now, at this phase, we have access to all the previous client data. So we can look at the DOM, we can look at browser globals, but now we have access to React's APIs. We have access to kind of all of your code that you've like imported into your big client bundle. That's all been kind of imported now. And in terms of benefits, this is kind of just the default, right? You're just kind of like writing your React component, you're doing things, you're using state, you're like writing stuff, and you're rendering. Now the constraints here are you have to deal with some server client differences, right? So if when the HTML came from the server and had something in HTML, and then when your React starts up and has something different, well, now that's like a conflict that React will kind of warn you about. And then the final step is this async client data present step, which is, you know, when you kind of initialize on the client, often you're going to make a lot of like fetch requests to get some asynchronous data. And until those kind of come back, you're often showing a loading state. And then when that stuff comes back, then we enter this next phase. And what you have access to is all the previous client data, but then also now the results of this async data. And the benefits here is you finally have everything you need to render the page, right? Like we went through all these steps, and now we finally have everything. We can like get rid of all of our loading spinners and finally render everything. But the constraints here are that things are kind of slow, right? Like this takes some time. So we have to like manage this asynchronous state and kind of have like loading states or like an error state if something goes wrong. So now given this understanding, we can go back to the examples from earlier and kind of see which trade-offs they were willing to make and which ones they weren't. So if we look at Instagram, for example, they show this big loading spinner immediately and then have lots of these kind of smaller loading spinners. And so Instagram decided to make their build phase very, very simple and just put this big loading spinner. And then they wait all the way until this async client data present phase to actually show something. So their first paint is nearly identical to their build phase, and their hydrate phase is also nearly identical. And then after the async data comes in, then they start to change things. But Best Buy is a little bit different, right? Their first paint has basically the entire screen, except this header is a little bit different. So they've done a little bit more at build time. They've kind of rendered out this entire page, except for the header. And the header, they move all the way into this async client data present phase, where they wait until they have that data. So what that means is their first paint is like a little bit more contentful, like you see more, but you still have this kind of flicker. So if we go back to my example here, you'll notice that there is no flicker. But we notably are not doing anything at request time. We're not doing anything at request time. And this is really important because if you're doing something at request time, it makes it quite easy to get a good first paint because you have access to, like in this example, we're talking about authentication, right? So we have like a user's profile picture and we can sign out and then above that, and then we can sign in and reload and the profile picture shows immediately. And we're doing this without request time information, which is really important because if we did this, this slows us down. It's really slow, right? Like serving a static asset from a CDN is like 20 to 30 milliseconds at most. Doing SSR where you're blocking on like a database request to check authentication is like 200 to 300 milliseconds, maybe more, right? So this is like a whole order of magnitude difference. So if you think about what we're left with, we have to have something during the build phase, even though we don't know whether the user is signed in or not. But then we only find out when the user is signed in or not all the way over here in the async client data present phase. But in order to not have a flicker, we need to have a perfect first paint. So what can we do? Well, what does this first paint have access to? It's access to the DOM and browser globals. And so that's what we're going to use to make sure our first paint is correct. We're going to, use the DOM in an inline script tag before React even runs, before React hydrates, to make sure that even though our the HTML that initially comes down from the CDN, which doesn't know anything about, like, which doesn't have the information that we need at request time, we can get that information and update the DOM in an inline script tag before first paint, before React updates, so that we never see a flicker of that stale state. So to introduce this concept in a slightly gentler way, I have this example of a clock, which if you see when we reload, the broken one has this weird flicker and the fixed one doesn't. And what this is that the broken one, kind of this state in the top left, is the state that's from build time. And the state that it kind of jumps to is the state that's at hydration time. And you can see the fixed one doesn't have this problem. And we'll take a look at how. But what the fixed one is going to do is, like, in this paint phase, it's going to correct the initial position of that hand from the build position to the current position. So let's take a look at how this is done. So if we check out our clock component, it's pretty simple. We have some state with a date and then a use effect that updates that date every 10 milliseconds. Then we render this second hand with this rotation attribute that's kind of derived from the current time. And you can see the only difference here is that the clock in the fixed one has this special ID and then this inline script. And so this ID second hand will be important when we look at the inline script. And so what the inline script does is it first gets the second hand using document.getElementById. Then it calculates the date, kind of derives the same calculation that's used in the React component, and then manually sets the attribute of the SVG. And this script, we put it, right after that clock in the DOM. And so the browser, when it's parsing the HTML, will actually run and execute this script and update this attribute before it ever even paints. So by the time the user kind of sees anything at all, that kind of little flip from the build state to the paint state has kind of happened without the user even noticing, which is really, really cool. And then the next example I have is this input example, where if we reload and then type in both of these inputs, you'll see that when React hydrates, it kind of clears out this broken one. And so if we look at what's happening here, if we go to input, we'll see that we have this input, and you can kind of just ignore this for now. And the input state is initialized to an empty string. And so when React hydrates, it sees oh, the input value is an empty string, and kind of sets that input value to an empty string. And so if you've typed anything in there, then it will wipe it out. And so what we can do is use the useState kind of initializer function to once again get the element by its ID, and then initialize the React state with the state of the DOM, which might have updated since the build time HTML. And so just to show you that once again, this fixed version, the React state initializes with the state from the DOM. And so now we're going to combine these two in our final authentication example. Now when we're logged out, everything looks pretty much the same, but if we log in, then you'll notice when we reload, the profile picture appears instantly. Now this wouldn't actually be instant if you had never loaded your profile pic before. It's kind of relying on the browser caching that image. But if you think about, in most cases, this would be fine. And the way this works is that we're storing the URL for the profile picture in a cookie. And so again, if we think about what information is available at what times, well, document.cookie is a browser global. And so we can access this cookie before first paint in an inline script tag, and then set that attribute in the DOM. And so we can have a perfect first paint, and then when React hydrates, it can kind of pick up where we left off. And so let's take a look at how that's implemented. So most of the logic is in this script tag, and this one's a bit more messy than the last one, and this is definitely not the kind of code you want to be writing all over your app. I think it's just, if you really need this in some very isolated cases, I think it's fine. But what we're doing is we're reading document.cookie, we're parsing the cookie, we're getting our profile picture URL, and then we're creating a image element and appending it to this auth div, which we get by the ID. And that auth div comes up here, and this is kind of the div that holds this thing right here. And so before first paint, we just set that immediately to the image tag. And if we sign out, because that cookie goes away, then this logic never runs. The one thing that is important to know is that Most session cookies are marked as HTTP only, which means that you can't access them from JavaScript. And this is very intentional. You probably don't want to put your entire session cookie in a non-HTTP only cookie. But you can kind of have, I made the second metadata cookie, which is not encrypted and not HTTP only. And this is like pretty safe to do because you would only ever put like public information in this cookie. And it would also always be derived on the server from your session. So like the user, even if they like set this on the client, it wouldn't actually do anything on the server. And so this is how you can kind of still have a safe encrypted session cookie while still having a publicly accessible kind of metadata cookie that you can access at paint time in JavaScript. If you're curious about this, you should definitely check out my blog post. It's called A Clock That Doesn't Snap, where I kind of go in a bit more detail about how this works. All of the preview link and the GitHub to this are linked there, and they'll also be in the description. And if this is interesting to you, definitely comment below, and I'll see you in the next one.